In this video, we want to construct a grouped frequency distribution and summarize a seemingly haphazard or random collection of data. In this particular example, I've got a sample of 25 basketball players and the number of points that they scored at a recent high school tournament. And we want to organize this data somehow so we can glean some kind of meaning out of it. And the very first step in this whole process is to determine the range of the data. The range is the difference between the highest value and the lowest value. And so in this particular case, the range is going to be the largest value, which is 33, minus the smallest value, and in this particular case it's 5, and that is going to give us a range of 28. And now that we have calculated the range, we want to determine how wide each of our classes is going to be. So the class width is determined by taking that range that we just calculated and dividing by the number of classes that we want to use. If your range is rather small, you can use a small number of classes. And if the range is large, and some data sets have ranges in the tens of thousands, then you'll want to use a larger number of classes, possibly as many as 20. In this particular case, our range is rather small, and so we can get quite a bit of detail out of the data by just using 5 classes. So in this particular case, I'm going to divide by 5. And when I do that, 28 divided by 5 is 5.6, and if your class width is a decimal number, you always round up to the next whole number. So each of our classes, when we have constructed our frequency distribution, is going to be 6 units wide. At this point, we are ready to construct our grouped frequency distribution. And to do this, we need to create a series of columns. So create a table. That's a terrible straight line, isn't it? You'll need at least 5 columns. I can do better than that. There we go. That's much better. Now, to construct the frequency distribution, we need to label each of our columns. The very first column is going to be the class limits. The second column are the class boundaries, and we'll see why that is important here in just a few minutes. The third column is going to be our tally column. That's when after we've constructed our limits and our boundaries, then we go through the data and assign each of the data values to one of the classes. And then we convert our tally marks to frequencies. And finally, I like a cumulative frequency column. You can also do a relative frequency column if you wish, but I like the cumulative frequency, and we're going to need that cumulative frequency column when we construct an ogive later. And now we're ready to go through the data and start constructing our boundaries and limits and everything else. So the very first thing that we're going to do, that we need to construct our first lower class limit. We're going to have 5 classes. We know that each class is going to be 6 units wide, and we're going to start by producing our first lower class limit, which is going to be equivalent to the smallest data value that we have in our data set. And in this particular case, our smallest data value was 5. So we're going to let 5 be the very first lower class limit. I'm sorry, I had to make an adjustment to my pen size. And so our first lower class limit is going to be 5. And now that I know I want 5 classes and each class is going to be 6 units wide, I can keep adding 6 until I've calculated 5 lower class limits. So 5 plus 6 is 11, and 11 plus 6 is 17, and 17 plus 6 is 23, and 23 plus 6 is 29. And we've calculated our lower class limits. Now we need to calculate our upper class limits. And our first upper class limit is going to be one less than the second lower class boundary. Because if you think about it, if you're counting, if I start with 5, and I know that each class is going to be 6 units wide, starting with 5, that would encompass 5, 6, 7, 8, 9, and 10. So our first upper class limit is going to be 10. And then, because I know my class width is 6, I can just keep adding 6 to each of these upper class limits until I've calculated 5 of those quantities. So the third class will run from 17 to 22, the fourth class will run from 23 to 28, and the fifth and final class will run from 29 to 34. And there are our class limits. And now we need to calculate our class boundaries. Well, the class boundaries, you'll notice that there's a gap between the first upper class limit and the second lower class limit. The boundaries help remove those gaps and assure a continuous distribution. The data, the raw data, the number of points scored are all whole numbers, so the smallest unit is a whole unit. We're going to take half of a whole unit and subtract from each of the lower class limits and add a half to each of the upper class limits, and that will create a continuous distribution for us. So 5 minus a half is 4.5. That'll be the first lower class boundary. And if I add a half to the first upper class boundary, that is going to be 10.5. And we read that as the following. The class boundaries for the first class are any data value larger than 4.5 up to but not including 10.5. Because if a data value reaches 10.5, we would round up to 11, and then it would get knocked over to the second class. And now that I know I've got my first lower and upper class boundary, I know each class is going to be 6 units wide, so I can keep adding 6 to all of the boundaries until I've completed the column. So 4.5 plus 6 is 10.5, and 10.5 plus 6 is 16.5. And 16.5 plus 6 is 22.5, and 22.5 plus 6 is 28.5. And now I do the same thing to the upper class boundaries. So 10.5 plus 6 is 16.5, followed by 22.5, and then 28.5, and finally 34.5. And there are my boundaries. And now the boring part of this whole process is over with. Now it's time for the fun. This is where we go and assign each of the data values to one and only one class. So starting with our, we need some more color here. So let's go through the data. The very first data value in the data set is 12, and it's going to get assigned to the second class. And then 16 gets assigned also to the second class. 19 falls in the third class. 8 gets assigned to the first class, and 12 gets assigned to the second class. And then we have 23, so that goes into the fourth class, and 18 goes to the third class, and 12 goes to the fourth class, and 9 is the first class, and then 16 gets assigned to the second class. So we've already got 5 observations assigned to that second class. And continuing on, we have 17, and that's the third class, and then 15, and that's the second class. 33, there's our largest data value in this data set, and then 9 and 10, so those 2 values get assigned to the first class. And then 16 goes in the second, and 24 gets assigned to that fourth class. 5, which is the smallest data value, goes in the first class. 29 gets assigned to that fifth class, and 20 gets assigned to the third class. And the final column of data, 17, goes in the third class, so we've got 5 there, and 12 goes in the second class, and then 9 gets assigned to the first class, and we wrap this up with 15, and finally 23. And there is we've assigned the data values to one and only one class. You can't assign a data value to more than one class at a time. And now we're ready to convert our tally marks to frequencies. So the first column has 6 observations, the second class has 9, the third class has 5, the fourth class 3, and finally 2. It would probably be a little bit neater if I had drawn horizontal lines to separate the columns and the rows. The final column is a cumulative frequency column, and we are going to keep a running total of how many observations in our data set have been accounted for as we pass through each class. At the start of this whole thing, we haven't accumulated any observations. But if I add the 6 observations to the 0 that I started with, 0 plus 6 is 6. So after the first class, 6 of my data values have been assigned. The frequency and cumulative frequency will always be the same for the very first class. Now I'm going to take the 9 observations from the second class and add it to the 6 observations from the first class. And so after the second class, 15 of my data values have been accounted for. Then I'm going to take the 5 observations from the third class and add it to the 15 observations that have been accumulated through the first 2 classes to give me 20. Then the cumulative frequency after the fourth class is 23. And finally, when I add 2 to 23, I get 25. And if we've done this correctly, the cumulative frequency, the last value in that column, will equal the number of data values that you have in your data set. Coming up next, a video on constructing histograms and histograms and ogives, from a group frequency distribution. See you then.